Hello, let's discuss cranial nerve 3, 4 and 6. Cranial nerve 3 is called oculomotor nerve, cranial nerve 4 is trochlear nerve and cranial nerve 6 is abducens nerve. We are discussing these nerves together because all of these three nerves gives innervation to the extraocular muscles. Okay, and all of these nerves originates from the brain stem. The oculomotor and trochlear nerve originates from the midbrain part of the brain stem, while the abducens nerves originates from the pons. Okay, one unique thing about the oculomotor nerve is that it is also a parasympathetic nerve because it gives parasympathetic fibers. Okay, all of these nerves are motor nerve. Okay, it gives motor innervation to the extraocular muscle, but the oculomotor nerve, along with its motor innervation, it also gives parasympathetic innervation. Okay, so let's discuss the first we will discuss the oculomotor nerve, its course and its innervation. So after these are the oculomotor nucleus in the midbrain. These are the motor nucleus, and this one nucleus is Edinger-Westphal nucleus, which is parasympathetic. So after exiting the midbrain, it travels in the lateral part of the lateral wall of the cavernous sinus. We already discussed it that in the lateral wall there are four nerves: oculomotor nerve, trochlear nerve, the ophthalmic nerve and maxillary nerve, while the abducens nerve runs inside the cavernous sinus. So after exiting from the midbrain, the oculomotor nerve then travels in the lateral wall of the cavernous sinus. Okay, so it enters into the cavernous sinus lateral wall. Then after exiting from the cavernous sinus, it passes through this fissure, which is called superior orbital fissure. So this is the oculomotor nerve enters into the superior orbital fissure, and it divides into two branches or two division: superior division and inferior division. Then this superior division gives innervation to the two muscle. Okay, so the first muscle is this one, levator palpebrae superioris, and the second one is this muscle, which is superior rectus muscle. What is the function of the or action of the levator palpebrae superioris? Levator, it means elevation, palpebrae mean eyelid, and superioris means superior. Okay, so what it does, it elevates the eyelid. Okay, so it helps in opening of the eyelids. Okay, and if there is lesion of the oculomotor nerve, so due to paralysis of the levator palpebrae superioris, there will be complete ptosis or drooping of the eyelid. Okay, so the superior division gives innervation to the levator palpebrae superioris, and the second muscle is superior rectus. So what is the function of the superior rectus? Superior rectus do elevation of the eyeball, plus it also causes the adduction of the eyeball. Okay, so superior rectus action is elevation of the eyeball, okay, and adduction of the eyeball. These are the two functions of the superior rectus, and it is innervated by the superior division of the this oculomotor nerve. Now the inferior division give innervation to this muscle, which is medial rectus. Okay, it also gives innervation to this muscle, which is inferior rectus, and this muscle, which is inferior oblique muscle. Okay, so inferior division gives innervation to the three muscles: medial rectus, inferior rectus and inferior oblique. Now what are the functions of these three muscles? First, the medial rectus. Okay, so medial rectus causes the adduction of the eyeball. This is medial rectus, this is medial rectus. It causes the adduction of the eyeball, while the inferior rectus, superior rectus do elevation and adduction, while the inferior rectus will cause depression and adduction. Okay, so both of the recti muscle, superior and inferior recti muscle, will cause adduction, but the superior rectus will cause elevation and adduction, and inferior rectus will cause depression and adduction. Okay, now the third muscle which is supplied by the inferior division of the oculomotor nerve is this inferior oblique. So remember, the oblique muscles will do the opposite action opposite to the recti muscle. Okay, so the inferior rectus action was depression and adduction. Now the inferior oblique will do the action opposite to this inferior rectus. Okay, so it will cause elevation and abduction. Okay, inferior rectus action was depression and adduction, but now the inferior oblique will do opposite to this action. It will cause elevation of the eyeball and abduction of the eyeball. Okay, and inferior oblique muscle is innervated. This is inferior oblique muscle. It is innervated by the inferior division of the oculomotor nerve. So the Edinger-Westphal nucleus gives parasympathetic fibers. It runs in this oculomotor nerve, and then it enters into this ganglion, which is ciliary ganglion. Okay, so this is ciliary ganglion. Ciliary ganglion also receive fibers from this inferior division of the oculomotor nerve, and then it supplies the two muscles. Okay, so the parasympathetic fibers from the ciliary ganglion gives innervation to the two muscle. One is ciliary muscles and the second one is sphincter pupillae, and these muscles causes the closing of the pupil. Okay, or you can say the constriction of the pupil, which is called meiosis. It will cause meiosis of the pupil. This is pupil. Okay, this is pupil, and it will cause constriction of the pupil or meiosis of the pupil. Now if there is lesion in the oculomotor nerve parasympathetic fibers, so when there is lesion in the parasympathetic fibers of the oculomotor nerve, it will lead to dilation of the pupil, or you can say mydriasis of the pupil. Mydriasis of the pupil mean the dilation of the pupil. Okay, so these are the parasympathetic fibers of the oculomotor nerve. Now we will discuss about the trochlear nerve, cranial nerve 4. It also originates from the midbrain, but the unique thing in this trochlear nerve is that it originates on the posterior border, or from the posterior of the brainstem. Okay, so it arises from the posterior wall of the brainstem, and then it exits from the brainstem interiorly. Okay, it arises from the posterior wall, then it exits the brainstem. Okay, it exits the brainstem, and then it runs in the lateral wall of the cavernous sinus, just like the oculomotor nerve. Then it passes through the superior orbital fissure. Okay, this is the superior orbital fissure, but outside this ring, this is common tendinous ring. It travels outside the tendinous ring to gives innervation to this muscle, which is superior oblique muscle. It just supply or it only gives innervation to this one muscle, which is superior oblique muscle. And now, as we already mentioned, that oblique muscle will do action opposite to the recti muscle. So the superior rectus do elevation and adduction. Now the superior oblique muscle will do the opposite action to the superior rectus. It will cause depression and abduction. Okay, depression and abduction. So this is the action of the superior oblique muscle. Now the third nerve which also supplied the extraocular muscle is this one, abducens nerve, cranial nerve 6. This is the abducens nerve nucleus. It originates from the pons, then it travels in the cavernous sinus. But as we mentioned before that in the cavernous sinus, it will be inside the cavernous sinus along with the internal carotid artery. Internal carotid artery and abducens nerve travel inside the cavernous sinus. Okay, so after exiting the cavernous sinus, it travels or it passes into this fissure, which is superior orbital fissure, and it gives innervation to just one muscle, which is this one. This is lateral rectus muscle. Okay, lateral rectus muscle, the only muscle which is innervated by the abducens nerve is lateral rectus muscle, and lateral rectus muscle does the abduction of the eyeball. Okay, so medial rectus causes the adduction. Okay, adduction of the eyeball, which is supplied by the oculomotor nerve, while the lateral rectus causes the abduction of the eyeball, and it is innervated by the abducens nerve. Okay, now we will little bit discuss about the gaze of the eyeball. Okay, so there are major two types of gaze: vertical and horizontal gaze. Okay, so the vertical and horizontal gaze. So this is the vertical gaze, vertical upward gaze, and the vertical downward gaze. So the vertical upward gaze, it is the two muscles do this gaze upward, vertical gaze. Okay, superior rectus and inferior oblique. So inferior oblique and superior rectus both causes the upward vertical gaze. Okay, and both of these muscle is supplied by the oculomotor nerve, and the nucleus the nucleus of the oculomotor nerve from the both side is connected by the commissure, which is called posterior commissure. Okay, now the vertical downward gaze, it is carried out by the two muscle, inferior rectus and superior oblique. Okay, inferior rectus is supplied by the oculomotor nerve, while the superior oblique by the trochlear nerve, and both of these nerve has nucleus which is connected by the medial longitudinal fasciculus, or MLF. Okay, now these are the vertical gazes. Now the horizontal gazes. The horizontal gazes will be carried out by the lateral rectus of the one eye and the medial rectus of the other eye, and both of these lateral rectus is supplied by the abducens nerve, while the medial rectus is supplied by the oculomotor nerve, and both side nucleus is connected by the same medial longitudinal fasciculus. Okay, medial longitudinal fasciculus. Now the vertical gaze has the nucleus which is called nucleus of Cajal, while the horizontal gaze nucleus is para abducens nucleus. Okay, so this is little about the gazes of the eyeball. So this is all about the oculomotor, trochlear and abducens nerve.